Hi, welcome to Algebra Honors Unit 8, Day 2. We are doing quadratics, and Day 2 we're going to be solving quadratic equations by graphing and factoring those equations. So we have a quick warm-up review. You should try these problems by pausing the video and then come back and see how you did. All right, so from Unit 3, zeros of a function, that's where the whole thing equals 0. So your y value equals 0, or your f of x equals 0. So you're looking for what is the x that makes the whole thing equal 0. So the way I'm going to solve this is I'm going to say the whole thing equals 0. How do I get there? If I started out with 3x minus 6. And of course I'm going to add 6 to each side, and then divide each side by 3. So if I am looking for the 0 of that function, it is 2, x equals 2. Okay, so we can say x equals 2 in that order if we want. All right, what is the 0 of this function? Again, the whole thing equals 0, so 0 equals 1/2 x plus 5. That means negative 5 equals 1/2 x. If I want to get rid of a denominator, I'm going to multiply by it, so I'm multiplying each side by 2, so I have negative 10 equals x, or I can say x equals negative 10. Okay. If I were to graph that line, if I were to graph this, f of x equals 1/2 x plus 5, I would find that x equals negative 10 means that my x-intercept, happens right there. Let's see if I can bring this up. So look, when I graph y equals 1/2 x plus 5, one of my solutions where I cross the x-axis is right there at negative 10. And in fact, there's only one solution. Okay, so view. So x equals negative 10 is a solution. It is a 0 because that is where the whole function equals 0. Okay. Now over here, a review from Unit 7, we're going to factor trinomials. We just did this unit. Okay, so x squared plus 6x plus 9. If I happen to notice that I have a perfect square here and a perfect square here, this is a perfect square trinomial because 3x doubled is 6x. So if I notice that, awesome. If I didn't notice that, I can use my x puzzle to see what two numbers multiply to give me 9, but add up to give me 6. That's 3 times 3, right? So I can solve it that way, and I see that I have x plus 3 times x plus 3. But of course, that really means x plus 3 squared because it was a perfect square trinomial. Okay, then our last factoring over here, 2x minus 7x plus 3. I'm going to use my x puzzle. What two numbers multiply to give me 6, but add to give me 7? So remember, we multiply a times c. And since my a value is not 1, I have to actually either solve by grouping or by using the box method. So two numbers that multiply together to give me 6, but add together to give me negative 7, that's going to be negative 1 and negative 6. So if I solve by grouping, it's going to be 2x squared minus x minus 6x plus 3, right? I just broke apart negative 7x, so that is negative x minus 6x. Group, I'm going to take those first two and I'm going to pull out x, so I have x times 2x minus 1. And then I'm going to take out negative, so I'm subtracting. I'm going to take out negative 3, and I'm left with 2x minus 1. My two factors then are x minus 3 times 2x minus 1. I have factored this trinomial, and those are my two binomial factors. All right, so that's just your quick review. Let's call this a key. And just remember from our last lesson, a quadratic function. Oh, could you see all of that? I hope you could. My whole factor here. I hope you could see all that when I was doing it. Quadratic function is a function that can be written in this form, ax squared plus bx plus c. Okay. That's a quadratic function, f of x. A quadratic equation is what we're going to do when we say that we're looking for the 0. The whole function equals 0. So ax squared plus bx plus c equals 0. So we have a specific outcome we're looking for. Here, I can plug in lots of different x's and get different outputs, right? Here, I need to figure out what I plug in to have my output be 0. All right. Okay, so it's this quadratic equation where we set it equal to 0 that is going to be super important to us for this unit. All right, the x-intercepts, zeros, solutions, and roots. 1, 2, 3, 4. All of those four things are related. They're nearly the same. It kind of depends on how we write our answers, though. All right. So consider the graph of this quadratic function, f of x equals x squared plus 2x minus 3. The x-intercepts, if I graph it, are the points where the graph intersects the x-axis right here. These are my x-intercepts. Okay? The x-intercepts of the function that we are talking about are located right here at negative 3 and 1. Negative 3 and 1. Or if we wrote it as an ordered pair, it would be negative 3, 0, and 1, 0, because those are the points at which we cross that x-axis. The zeros of the function are located at, surprisingly, negative 3 and 1. If the whole value y is 0, if my y value is 0, these are the two x values that I can have. Okay, so the zeros are the values of x that would make the whole function f of x equal to 0. The solutions, or roots, of this equation, so now we have set it equal to 0, right? The solutions are negative 3 and 1. Okay, the solutions are the values of x that when you plug them in, make the whole equation equal to 0. Okay. So, solutions to a quadratic equation. Hold on one sec. Right. The solutions to a quadratic equation, or the zeros of a quadratic function, are the x-intercepts of that parabola. Okay, again, the solutions to a quadratic equation, or the zeros of a quadratic function, are the x-intercepts of that parabola. All right, so a quadratic equation can have two solutions, meaning two x-intercepts. So if that's my parabola, 1, 2, two places I cross that x-axis. We can have exactly one solution, so maybe that's my parabola, and I exactly touch that x-axis. Or I might have no crossing or touching of the x-axis at all, so maybe it just goes like that. Okay, never even touch the x-axis. Two solutions, 1, 2. One solution, 1. No solutions, doesn't even touch. All right. We talked a little bit in our Unit 8, Day 1, about if you can factor your equation and see two distinct binomial factors, then you have two solutions. If you can see one single unique binomial factor, you just have one solution. And a lot of times if you can't factor out that trinomial into any binomial factors, you might have no solutions at all. But there's a way to tell for sure how many solutions you're going to have. So you're going to use something called the discriminant. The discriminant is the value you get when you say b squared minus 4ac. b squared minus 4ac. That is the discriminant. That's what you call the value you get. So, remember, ax squared plus bx plus c. This is our a and our b and our c that we're talking about. If the discriminant, after you do the math, if the discriminant, so we're calling it d, right? If it's greater than 0, so if it's positive, then there are two real roots or solutions. And when I use the word real here, I mean real numbers, not imaginary numbers, okay? If my discriminant is exactly equal to 0, it's exactly equal to 0, so there's exactly one real root or solution. But if my discriminant is less than 0, then there aren't any real roots. There's no way to get a real root or a solution. Okay? So if your whole discriminant, when you do the math, if it's positive, two solutions. If it's exactly 0, if it's exactly something, you have one exact solution. And if it's negative, you have 0 solutions. All right, let's talk about finding the discriminant. Okay? Remember, discriminant is b squared minus 4ac every single time. So a here is 1, b is 5, c is 4. So my discriminant is going to be b squared minus 4 times a times c. 25 minus 16, which is 9. So 9, if it's positive, there are 2 solutions. Okay? Use the discriminant to find the number of solutions. We're going to say 2 solutions. 2 real solutions is what we're talking about. Okay? We don't care that the number itself that we got is 9. That doesn't have anything to do with how many solutions we have, except that it's positive. That's the only thing that we care about. Okay, over here, a is 1, b is negative 3, c is 10. So my discriminant is going to be b squared, use parentheses, minus 4ac. So I have 9 minus 40, so I have negative 31. Okay, negative 31 is a negative number. And so if I have a negative number as my discriminant, then I have 0 solutions. Okay, all we care about is 0 solutions, 1 solution, or 2 solutions. Let's look at this next one. A is 1, b is 10, c is 25. All right, and so b squared minus 4ac. 10 squared minus 4 times 1 times 25, 100 minus 100, excuse me, is 0. If my answer is exactly 0, that's the only, I care about exactly 0. I care about that number. If my answer is exactly 0, then I have exactly 1 solution. Okay, so come up with a way to realize that if it's exactly 0, your discriminant, that you have 1 solution. All right, over here, a is 2, b is negative 4, c is negative 3, so b squared minus 4 times a times c. I'm going to have 16 minus, it's going to be plus, right? 8 times 3 is 24. 16 plus 24 is 40. That's a positive number. So again, if it's a positive number, I'm back to having 2 solutions. The actual number here doesn't matter unless the number is 0, right? We care whether it's positive or negative or 0. Right, so solving quadratic equations by graphing, that is what we did a lot with our day 1. And so to solve a quadratic equation by graphing, we can identify the x values of our x-intercepts just by looking at the graph, okay? And we can see what the solution or solutions might be, and we can see how many there are. This right here, we touch that x-axis exactly 1 time at x equals negative 3. Okay, so there's 1 solution, and that solution is at x equals negative 3. Here I can say whoomp, whoomp, I have 2 different solutions, so I know that I have a solution at x equals negative 3, and another one at x equals positive 2. Okay, you can also write this x equals negative 3 comma 2. I think math space likes for you to answer that way. Over here, how many times do I touch or cross the x-axis? 0. There are 0 solutions. 0 solutions. So it's not that x equals 0. There are 0 solutions, or none, or no solutions. Okay? So be careful there. All right. Solving by graphing can be rather time-consuming, as you witnessed in our day 1 message. Okay, this method is also limited to finding real number solutions to a quadratic equation. So there are multiple methods, though, for solving quadratic equations. So let's take a look at what else we can do. We're going to solve quadratic equations by factoring instead of by looking at the graph. All right, so use this big idea, use your big idea. If a times b equals 0, what do you know about either a or b? Well, you know either a has to be 0 or b has to be 0 or both, right? So this is an important thing. This is one of the concepts that we're going to use when we are figuring out our solutions. So the 0 product property states that if you have a times b equals 0, then a equals 0 or b equals 0. right? One of them has to be 0 for that to multiply together and get 0. So when applied to quadratic equations, if the product of two expressions is 0, or if the product of two factors is 0, then one or both of those factors must equal 0. So if a quadratic equation factors 2ax plus b times cx plus d, then you know that if you're solving the equation equal to 0, either ax plus b has to equal 0 or cx plus d has to equal 0. Those are your options. That's it. One or the other, or maybe both. All right. So here's how we're going to use this information, this brilliance, to solve. We're going to set our quadratic function equal to 0. And then we're going to factor the non-zero side, right? We're going to factor probably a trinomial, if we can. And then we're going to use the 0 property and set each factor equal to 0, because one or the other must be 0. And so when we do that, we are possibly going to end up with two solutions, depending on how things factor out. Okay? All right. Solve the following equations by factoring. An equation is factorable if its discriminant is a perfect square. So remember, discriminant is b squared minus 4ac, right? From earlier in our notes, that's our discriminant. So if that is a perfect square, then it means we're going to be able to factor. Okay, solve by factoring. Well, this is already factored, right? We didn't even have a trinomial that we had to factor. But what I know is either x plus 3 equals 0 or x plus 5 equals 0. So if x plus 3 equals 0, then I'm going to subtract 3 from each side, and I know x equals negative 3. Okay? The other option is if x plus 5 equals 0. This works, right? So that means x equals negative 5. So my solutions are negative 3 and negative 5. X can equal negative 3, and it can also equal negative 5. If I look on a coordinate grid, I'm going to cross at negative 3, 0, and also at negative 5, 0. Okay, that's our answer here. All right. 2x plus 3 times 3x minus 1, all set equal to 0. I know this has to equal 0, or that has to equal 0, one or the other, or maybe both. Okay, so 2x plus 3 equals 0. I end up with 2x equals negative 3, and I end up with x equals negative 3 halves. That's one possibility. The other option is 3x minus 1 equals 0, which means 3x equals 1, and x equals 1/3. So it is perfectly okay to end up with fractions and weirdness. Absolutely fine. I would say that my answer here then is x equals negative 3 halves and 1/3. Those are my two solutions right there. All right, if you want to try some on your own, feel free. We're getting a little bit just more complex, and so we're going to have to factor this guy, because right now we have a trinomial. We weren't given two factors. Okay, and so I'm going to say I need two numbers that multiply to give me 21, but they're going to add up to give me negative 10. I think that's negative 7 and negative 3. Negative 7 times negative 3 is positive 21. Negative 7 plus negative 3 is negative 10. So since my leading coefficient started out as 1, I can just plug these guys in. I have x minus 7 times x minus 3 equals 0. That means x minus 7 equals 0 would be one solution, and x minus 3 equals 0 would be another solution. One of those two at least has to be 0. So x equals 7 and x equals 3. Those are options. And so I can say x equals 3 comma 7 as my answer. All right. X squared plus 10x plus 25 all equals 0. So I need two numbers that multiply to give me 25 but add to give me 10. And so 5 times 5 is 25, and 5 plus 5 is 10. I think that's pretty good. So what I'm going to do is factor. This is x plus 5 squared, right? Equals 0. There's only one binomial to even consider. Okay, or if I want, I can take the square root of each side, and I have x plus 5 equals 0. 0 doesn't get to be positive or negative. So I'm going to say x plus 5 equals 0, or x equals negative 5, like that. Okay, that's it. Okay, you can also think of this as x plus 5 times x plus 5 equals 0. So in this case, x plus 5 equals 0, and x plus 5 equals 0, but see how that's the same thing. Okay. Y equals x squared minus 64. Now remember, when we're looking for solutions, we're going to set the whole thing equal to 0. So I'm going to say 0 equals, I see a difference of squares, so that's x plus 8 times x minus 8. Difference of squares, right? So I know x plus 8 equals 0 is one way to get a solution, and x minus 8 equals 0 is the other way. So x equals negative 8, and x equals positive 8. X equals negative 8, 8. Those are my two options. And finally, f of x equals 3x squared plus 15x. Well, I'm going to say 0 equals, I'm going to factor out what I can. Watch this. I'm going to pull out 3x, and I have x plus 5 left. Right? 3x pulled out. I have two factors. It's just that one's a monomial and one's a binomial. That's okay, because I know 3x equals 0. And also, if I have x plus 5, equals 0, either one of these, this equals 0 or this equals 0, is going to make it true, yeah? So divide each side here by 3, x equals 0, and subtract 5, x equals negative 5. Those are my options. X equals negative 5 and 0. Both of those are solutions and would make my whole function equal to 0. Okay. X squared equals 8x. Well, that is not in standard form, so I'm going to put it in standard form. Okay. So I'm going to say that this is x squared minus 8x equals 0. Now it is a standard form quadratic equation. Okay, the whole thing is equal to 0, and I have it in descending order of exponents. Now I'm going to factor. So I'm going to pull out x, and I have x times x minus 8 equals 0. X must equal 0, or x minus 8 must equal 0. So x equals 0, one option. X minus 8 equals 0, another option. Add 8 to each side, and I have x equals 8. I'm going to write it like this, x equals 0, comma 8. That's my answer. All right, 2x squared plus 18 equals 15x. That is not in standard form. So I'm going to write it in standard form. So 2x squared, I'm going to be subtracting 15x from each side, right, to get that 15x moved over. And then I'm going to stick it in the middle so that I'm already in the order I want. Everybody okay with that? I subtracted 15x from each side. And I just went ahead and rewrote my equation so that it's in standard form. So now I want to find two numbers that multiply to give me 2 times 18, which is 36, but they have to add up to give me negative 15. Let's see, so 9 times 4 is 36, but 9 plus 4 would be 13. That's not it. Negative 12 times negative 3. Negative times a negative is a positive, so negative 12 times negative 3 is 36, and negative 12 plus negative 3 is negative 15. So that's my magic numbers. Since my leading coefficient is not just 1, I'm going to do this by grouping or the box. 2x squared minus 12x minus 3x plus 18 equals 0. I'm going to group, right? So I'm going to pull out 2x, and I'm left with x minus 6. And I'm going to pull out negative 3, so we have an operator there, right? We're subtracting. Negative 3, and I'm left with x minus 6. This all equals 0. I can rewrite this as 2x minus 3 times x minus 6, and that all equals 0. So 2x minus 3 equals 0, and x minus 6 equals 0, right? Well, I'm running out of room. So I'm going to pop on over here, okay, second section. So I have 2x equals 3, which means x equals 3 halves. And I have x equals 6, because I'm just adding 6 to each side. X equals 3 halves, comma 6. Okay, 2 more. Why don't you see if you can try these two on your own? Pause the video. Always, actually, before you pause though, always remember, granddaddy of all rules is take out any greatest common factors you can find first. So that's my hint. Okay, so I'm going to pull a 5 out of all of this. 5 leaves me with x squared minus 4x minus 12 all equals 0. If I want to right now, I can divide each side by 5, right? Why don't I? Okay, I can divide each side by 5 right now. So now I just have x squared minus 4x minus 12 equals 0. Now I'm going to try to factor that. I need two numbers that multiply to give me negative 12, but add to give me negative 4. And so I think that's going to be negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. My leading coefficient was just 1. Oops, can you see that? Sorry. So I know it's going to be x minus 6 times x plus 2 as my magic binomials. That all equals 0. X minus 6 equals 0, which means x equals 6. And x plus 2 equals 0, so x equals negative 2. So I can write this answer as x equals negative 2 comma 6. 3x squared plus 9x equals 12. Well, first I'm going to just write that as 3x squared plus 9x minus 12 equals 0. Then I'm going to pull out my 3. I have 3 times x squared plus 3x minus 4 equals 0. This time I'm not going to divide each side by 3 yet. I'm going to show you that it doesn't really matter in the end. So I'm going to keep the 3, and I'm going to write my two factors. Two numbers that multiply to give me negative 4, but add together to give me 3. I know it's going to be 4 times 1, so positive 4 times negative 1 is negative 4, and positive 4 minus 1 is 3. So I'm going to have positive 4 and negative 1. All right, so this time, this all equals 0. The 3 doesn't really matter, because if this is 0 or if that is 0, the whole thing will be 0, right? That's the multiplicative property of 0. So I don't really care about the 3, because once it's multiplying times any 0, it's going to be 0. So I know in this case then, x plus 4 equals 0, and the other possibility is x minus 1 equals 0. So x equals negative 4 and x equals 1. I can write it as x equals negative 4 comma 1. So in the end, I could have divided my 3 into each side first just to get rid of it. In the end, it doesn't really matter, right?